In Langchain, we have prompt templates. So prompt template generally has three components. First off, we have instructions for a large language model. Secondly, we have examples. So for example, if you are doing future prompting, we need to pass in some examples so that the model outputs more meaningful output. And lastly, we have the question, which is usually the user input. And so in this video, we are going to look at example selectors, which basically helps us select certain examples given a large set of examples. So as we know that OpenAI models, not only OpenAI, but in general, most of the large language models have a certain length on the input. That is, the context window can only take in a certain number of tokens as input. And so essentially we can't pass all of the examples into the prompt template and do any processing over it. And so essentially we need to find a way in order to select certain examples given a set of examples. And so example selectors in Langchain is a way in order to do that. And so let's quickly run the setting up code. So there are different classes which Langchain offers in order to select examples, and one of these classes is basically Custom Example Selector class. And so what it does is it basically allows us to create a custom logic in order to select certain examples. And so in this particular example over here, we are going to randomly select two examples from a list of examples. And so the first step is to import the base example selector from langchain.prompt.exampleselector.base. We essentially need to implement two methods. First is the add example method, which basically adds examples to a given set of examples initialized in the init method. The second method we need to implement is the select examples, which basically given a particular input variable or rather some input from the user, we need to return a list of examples. So our logic over here is to basically select two samples from the example list randomly. So over here, basically creating a very simple example list, instantiating the custom example selector class, and passing in the input variable. So as we can see, the example selector returns two examples randomly. We can basically use the add example method in order to add one more example to the examples, and again call the select example class to basically return two examples randomly. Next up, we have select by length, which is basically another logic implemented in the length-based example selector class. So the idea over here is to basically select examples based on the length of the input which is being passed by the user. So for example, if we have an input being quite long, so the number of examples being returned will be less. On the flip side, if the length of the input is short, we'll return more examples. So over here, again, we have list of examples. We initialize the example prompt, which basically formats the examples from this particular list of dictionaries into a string format. Finally, we instantiate the length-based example selector class, which takes in examples, the example prompt, and the maximum length of the formatted examples. Finally, we create the future prompt template, which takes in the example selector object, the example prompt, the prefix, the suffix, and the input variable in the suffix. And finally, call the format function on the dynamic prompt object by passing in the input variable. And so as the input over here is short, the number of examples being retrieved will be more. On the contrary, if the input is long, the number of examples returned would be less. Next up, we have Maxwell Marginal Relevance selection technique, which basically selects examples which are semantically similar to the input while also optimizing for diversity. So it does this by selecting examples with the embeddings that have the greatest cosine similarity with the inputs, while iteratively adding those examples and penalizing those examples if they are semantically similar with the already selected examples. So we need to basically import the Max Marginal Relevance Example Selector from Langchain Example Selector, and just for experimental purpose, we're going to import Semantic Similarity Example Selector, which doesn't optimize for diversity, but only selects examples which are semantically similar. We're going to import FICE, which is basically a vector store for storing embeddings and computing vector search, similarity search. And finally, OpenAI embeddings, which helps us compute the embeddings for a particular given piece of text. Again, similarly, we are going to have these examples, create the example prompt. Now over here, we are going to create the Max Marginal Relevance Example Selector example object by passing in the examples, the OpenAI embeddings, the vector store, which is FICE, and k equals 2 basically tells us how many examples do we need to retrieve from the vector store. And we basically create the prompt object by passing in the example selector class object, the example prompt, the prefix, suffix, and the input variables. So as you can see, for this particular input, the output the first example that gets selected is happy and sad, which basically tells us that it's working because worried is kind of semantically similar to happy and sad. And the second example which gets selected is windy and calm, which is further away from worried in the vector space. And just for experiment purpose, you're going to test out what two examples are being returned when we basically use semantic similarity example selector as the example selector. And so over here we basically get sunny and gloomy. The next technique is basically selection of examples by n-gram overlap. So over here, similarly, we basically select examples given a particular input variable from the user, which basically are semantically similar in terms of the n-gram overlap score. So we basically need to import the n-gram overlap example selector class from Langchain from example selector.ngram overlap. Similarly, create a list of examples and create an example prompt. So in n-gram overlap, we basically get a score from 0 and 1 included. 1 basically meaning that the input is having an exact match with the particular example from a set of examples, and 0 being that there's no overlap in terms of number of grams between the example and the input. So we'll test out different thresholds. So if the threshold is set to -1, by default all of the examples get selected. So as you can see, we basically have 3 examples. If we set a threshold of -1, all of the examples get selected. If we set a threshold of 0, only those examples which basically have some token overlap with the input get selected. As you can see, for this input, Spot can run fast. There's no overlap with my dog barks, and hence it doesn't get selected. Whereas if we set a bit higher threshold, that is 0.09, only those examples get selected which have a score above 0.09. And finally, as we had seen before, selection of examples by similarity is basically done using the semantic similarity example selector class. And we again import the FICE vector store and the OpenAI embeddings from Langchain embeddings. Again, instantiate the semantic similarity example class, pass in the examples, OpenAI embeddings specifies and k equals 1 in order to return or retrieve only one example. And so if we pass some other adjective, the output hopefully changes. And so yeah, it changes. And so that's all. These are the number of classes which are there in the documentation of Langchain. And thank you for watching the video. See you all in the next one.